Warmest regards to Mr. Ruli. Today, we are from Group 2, and in this opportunity, we will be presenting on our major assignment on the construction management at Pusat Otak National Hospital project. First, let me introduce to you the member of Group 2. There are SYAHREZA GHEVANNO ADISTA, RADEN HARYA, and myself, Rian Putra. In today's presentation, we will be discussing the project information, including the integration, scope, schedule, cost, and quality management at the construction of Pusat Otak Nasional, or also known as PON Hospital. So let us review the general information and a brief overview of the discussed project. The discussed project include the expansion from the existing building that will be utilized as the National Neuroscience Institute, and the project area is approximately at 25,464 meters square, and the area of building is approximate at the 95,000 meters square. So the project itself is located at Jalan MT Haryono, Kota Jakarta Timur, DKI Jakarta. And this project was started on the 15th December 2023 and expected to be finished before the 2025 New Year, specifically on the 31st December of 2024. There is also a building maintenance period from the 1st January 2025 until the 31st December of 2025. Moreover, this project contract is categorized as designed and built with a value of uh, approximate at 957 billion rupiah. This project also bound by high-level requirement criteria, which include the needs of achieving the green building aspect, which integrated with educational building, meeting the needs of space for Linac and Gamma knife, operation, MRI, CT scan, X-ray, cath lab, PET scan, SPEC scan, ICUs, and HCUs. So on the figure of on this slide, the area that are colored by the white color is actually the overall project area. As shown in the figure, the construction will mainly take place on the east side of the existing building, which denoted at alphabet A and B, which covers the construction of the new services and parking buildings, which denoted by the alphabet E and F. Moreover, since the hospital is meant to be the National Neuroscience Institute, therefore the construction process for the education research building is also being done, which denoted by the alphabet D. And also developing the land located in front part of the education research building as a healing garden, which denoted by the alphabet C. So the existing and the new constructed building will be connected by the bridges, which also included as part of the overall construction. So there are multiple stakeholders which involved in this project. These stakeholders are organizations that have the ability to make decisions that could affect the management and also the result of the project. And in the case of the construction of this building, as a teaching hospital, the stakeholders are separated into four categories, namely the owner, which are owned by Kementerian Kesehatan Republik Indonesia, and the contractors are PT PP Persero and also PT Wijaya Karya Persero. Uh, and the for the consultant, there are PT Yodia Karya and also PT Insan Mandiri Consultant. And lastly, for the last stakeholder is that the planning consultant, which is handled by PT Penta Rekayasa. So here are some of the photos that are taken directly by drone, which showing us the working progress. So on the left upper side, we can see that the drone were taking the photo immediately on the upper side of the building or the project. These photos show us the overall project site or also the project area, and the other three photos again taken by drone, and these photos are showing the overall progress from different perspective. In this slide, we are showing the overall organization structure. So here are the flow chart or the flow structure of the project organization, complete with the uh, name and also the job description.
Next, we will discuss about our project integration management, which will consist mainly of the work breakdown structure or WebS as well as the construction methods. Next, this is the flowchart showcasing the project scope of the construction work. There are multiple buildings in this project, namely the surface building, the parking building, as well as the educational building. However, we will focus mainly towards the parking building and focus even more towards uh, the lower structure of the parking building itself. So the following table is actually a part of the work breakdown structure of the project as a whole. On this particular part, we can see there's the procurement and there's also the parking building as well. The leftmost side shows the hierarchy, while the right one goes to be more specific towards the work packages. So we can see here, for example, for the parking building, there's the upper structure, the lower structure, as well as architectural. And for the lower structure, there's the watering process all the way towards the construction of stairs for its work packages. And there are also more for the other parts of the parking building as well for its upper structure and its architecture. This particular part of the work breakdown structure shows the surface building where underneath that there are uh, underneath the surface building there is its lower structure, upper structure, its architecture, its facade, and also its MEP. Again, it works the same way as the previously shown work breakdown structure part of the parking building. Again, this is actually an entire work breakdown structure, just we show it on different parts on this particular presentation so that it is more easily seen by the viewer. So again, it is the same for the lower structure. It has the water process all the way towards the construction of stairs, but there are also different differences because there are different floors, different amount of floors for each building. And in the case of the surface building, it also has facade and MEP as well, which the parking building does not. Next, for the educational building, it is very similar to that of the surface building as well. It has uh, underneath the educational building itself, there's also its lower structure, upper structure, architecture, facade, and also MEP. Again, it has its own work packages for each of the different parts of the educational building. Next will be about the construction method for each of the work package on our project. So there are multiple construction methods. In some cases, there are multiple construction methods for each of the work package. For example, for the dewatering process, we have the well point system as well as deep well system. Uh, There's also the precast column or the cast in place for most of the structural parts of the building, namely columns, beams, shear wall, and some other parts as well. Mainly have two construction method options, which again are the cast in place or precast. And there are also some other different construction methods for each of the work package shown in the work breakdown structure of this project. While the previous slide shows the construction methods as well as the work breakdown structure for the parking building, this particular slide shows the construction methods for each of the work package on the surface building. It is very much the same when it comes to the same work package. It has again two construction methods for most of the structural parts, or at least the upper structural parts of the building, which is the cast in place or precast for columns, beams, and so on. But again, there are different construction method. For example, for the foundation, there is the spoon pile and there's the board pile, and so on and so on. This particular slide shows the different construction methods that can be used for each of the work package for the educational building, which is again very much similar to the previous two buildings that have been mentioned, namely the surface and also the parking building. The construction methods available for each of the work package is very much the same. So moving on towards project scope management, where we will focus mainly towards the foundation as well as the sloof or tie beam and also the pile cap as well, but still mainly focused towards the foundation of our observed project. So when we are discussing about foundation, of course, we will need to look towards the soil condition on our particular site. And here we have a map that shows the different soil types across the province of DKI Jakarta. And it can be analyzed from this map that on our particular uh, project site, it has an alluvial fan type of soil, which is described to have bedded fine tuff, sandy tuff, and also interbedded with conglomeratic tuff. So next we will discuss the possible construction methods that can be used on foundations. There are mainly two different construction methods that are mainly used for foundations. First is the board pile method, and second is the spoon pile method. So when it comes to board pile, it should be noted that our construction site is located quite close to housing settlements, and therefore, in this particular case, board pile is actually more preferable because it doesn't produce as much noise as spoon pile would, which is more ideal for a construction site that is located quite close to housing settlements. It also has some other advantages, namely it is more cost effective in large complex projects, and it also produces less displacement of soil. When it comes to its disadvantages, it is more time consuming and also needs more detailed site investigation. When we consider the soil condition, which we discussed on the previous slide, Burpile is actually more suitable for that particular soil condition as well. However, in choosing which construction method is more preferable, there are also some other considerations, namely our very tight project schedule, which aims so that the project will take no more than 385 days. And in this case, spoon pile is actually way more preferable as it is way more simple and it doesn't require as much time to do than board pile does. It also has some other advantage, which is it has low maintenance, but for its disadvantages, it has noise disturbance and high initial manufacturing cost.
Now we will continue to the project schedule management. To know each duration of work on a work activity is to do several methods in identifying how many workers that we need or how many days that it will take to the work to be done. So in this method, we decided to use to know how many days it will take if a total of several workers that is used for that type of work. So in this case, we need to first determine the volume of the work, which can be obtained from methods like quantity takeoffs or many others. So in this category, we define work coefficient for each activity, and to this is done to know the productivity of the each work. The productivity is the coefficient times the volume of the work. So know the duration for this is by dividing it with the personnel that we use for this type of work. So we decided to use around 5 workers, 5 mason, and one foreman for this work, which result in a total of 54 days to be estimated. For this calculation applies for the further of this presentation, and the same for each other work. In the work of bore pile reinforcement bars installation, it is in total there are a total volume of 44,088 kilograms of reinforcement bar that needs to be installed. The duration of this working process are determined to have a duration of 19 days in total, with a team that consists of 7 workers, 7 blacksmiths, and 2 foremen. For the work of bore pile casting, a total volume of 2,425 meter cubic is needed for all the bore piles to be casted. It is said that a total personnel of 90 people that is needed, which consists of 70 workers, 12 masons, and a total of 6 foremen. With the personnel to be this amount, the whole working process can be done within a duration of 12 days. Continuing on further for the project is the sloof and pile cap casing installation. The work volume that is needed in this project is around 674.51 meter squared of area in sloofs and 926.09 meter squares of area of wood that is needed for pile caps. For this work volume, it is decided that it requires a total of 36 workers, 18 carpenters, and 3 foremen for sloof work, and a total of 41 workers, 21 carpenters, and 4 foremen for pile cap for the work to be done in a total of 10 days for sloof and 12 days for the pile cap. Continuing on the sloof and pile cap reinforcement installation, this work has a total of needed 36,000 kilogram of reinforcement bars for sloof installment, and a total of 346,000 kilogram of reinforcement bar for pile cap installment. For this work, it is required for around a total of 7 workers, 7 blacksmiths, and 2 foremen for sloof work, and a total of 48 workers for the blacksmiths and 12 foremen for a pile cap. For the work to be done in a total of 9 days for sloof and 12 days for pile caps. For the casting process for sloof and pile cap, it needs a total volume of 128 meters cubic of casting and a 2098 meter cubic of casting for pile caps. For this type of work, the author decided that it requires a total of 9 workers, 3 stonemasons, and 2 foremen for sloof works, and a total of 72 workers, 18 stonemasons, and 10 foremen for pile cap for the work to be done in a total of 4 days for sloof and 8 days for pile caps. Continuing on the curing process for sloof and pile caps, the provided volume are on a unit of meter cubics, where it shows the required volume that it needs to be managed during the concrete curing process. For this type of work, the author decided that it requires a total of 2 workers and 1 foreman for slough works, and a total of 3 workers and 1 foreman for pile cap works, to be done in a total of 7 days. In the work of casing removal process for slough and pile caps, the total volume is as stated above is on a units of meter squared, where it shows the required amount of casing to be removed. For this type of work, the author decided that it requires a total of 6 workers and 1 foreman for slough work, and a total of 9 workers and 1 foreman for pile cap works, for the work to be done in a total of 5 days. So from the previous scheduling methods that we use to determine the duration of each works, we can provide a precedence diagramming method, or a PDM, for bore pile work foundation. The PDM method is done to know which activity comes first or which activity comes after the work. It is done to know which are the predecessor and which are the successor of the work. So for this type of work, which is bore pile, for the volume that is used for the foundation work is as much as 572 piles, with a total target duration of 107 days, which in this case is very far off, with a total days of 138 days, accessing the target project duration. So from the previous PDM method, we can determine the work sequence for a bore pile work, continuing to pile cap and slough. So in this diagram, FS state as a finish to start, while SS state as a start to start. The +7 is the lateness of the work that is done. So for the bore pile, the sequence starts from the preparation for field and heavy equipment, the bore point setting, the bore point process, the casing installation, the the reinforcement bar installation, the casting process, and the curing process. So from the curing process, there is actually 2 work that can be done, which is testing and the metal preparation of for slough and pile cap work. After the preparation is done, we can continue to the installment of the casing for both pile cap and slough, which is done at the same time, and it can then continue to the installation of the reinforcement bars. After both pile cap and slough reinforcement bar is done, the worker can continue to the casting process of the work, which after it's done is the curing and the casing removal of the work. Then the work can completely be done. So to compare the work activity of Borpa, we decided to add another construction method for foundation work, which is spoon piles. So for spoon piles, we actually obtain several documents of the existing work, of the same volume of the spoon pile, which is a total of 572 piles, and a target of 107 days. So from this PDM and duration that we've obtained, it is the target working duration is a total of 106 days, which is sufficible from the target of 107 days, making the whole working within the project to be on time. From the previous PDM, we can continue on the work sequences for spun pile, pile caps, and slough. So for slough itself, for the spun pile itself, it starts with the procurement of the spun pile with a diameter of 600 millimeters, the handling of the spun pile, the whole handling of the dolly, the bow plank and marking, and the piling of the spun pile itself. Then it is the work to be done is to connecting and the treatment of the spun pile, the dolly work, and after that it can be done there's two works that can be done, which is the testing and the material preparation for sloof and pile cap work. For sloof and the pile cap work, it is actually the same as the for bore piles. It's with casing installation, the reinforcement bar installation, the casting process, the curing process, the casing removal, and the project is ended. So from the previous PDM and work sequences, we can continue on making the critical path method for both the construction method that we chose, which is the bore piles and the spun piles. So from the previous PDM, we can actually make a Gantt chart for spun pile foundation work. It describes the duration of the works, the predecessor of the work, and the the dates of where the project should start and end. So these are the Gantt chart that we obtain from our analysis. So continuing with the critical path method, which is a method to know the shortest amount of project that time that a project needs to be done. So from this diagramming, we can see that for all those work, there is actually a zero float, which indicates that the work there cannot be late or delayed. This means that this work is important for the project to be done on schedule. Continuing on from the previous diagram is the continuous of the work of Spanpal and continuing to the power cap and sloof work. So from this diagram, we identify several floats on the work of sloofs with indicate several floats, which means that the work can be late for several days, which is provided in the diagram. This last diagram shows the last phase of the project, which shows zero float also to finish the work on time, which is indicated to finish at the 105th day if the work is not delayed or is scheduled on time. So moving on to the bore pile foundation work, here is the Gantt chart that we have obtained from our previous analysis. It shows the predecessor, the duration of the works, and the start and end date of each work. So moving on to the critical path method for bore pile foundation work to know the duration of the shortest duration for the bore pile foundation work and sloof and the pile cap works. So in this diagram, it shows that there is no float allowed, which means that all the works done here needs to be done on time. So for this diagram, it continues from the previous diagram, which shows there are several floats here and there for the sloop works, which is provided by the float um, from the diagram, indicating that the work can be done late as the provided floats. So in this diagram, it actually shows the last phases of the bore pile, sloof, and pile cap works. In this diagram, it shows that there is no float allowed for the project to finish on time. Um, from the analysis that we've done, the project will end on the 137th day if the work is on schedule.
Entering the project cost management, in this part we will be conducting an analysis specifically on the cost aspect of both working method, which are bore piling and also spin piling. Just for an additional information, due to the lack of information regarding the analysis harga satuan pekerjaan of spin piling, Therefore, the existing bill of quantity or BOQ of the project will be used in this case to be compared by the bill of quantity of bore pile that we have calculated manually according to the material that are given during the class. Entering to the analysis harga satuan pekerjaan of working method from bore piling. So the first activities is the boring of 1 meter bore pile with a hole of 600 millimeter diameter, and these coefficient are taken from directly from the peraturan pemerintah of the Indonesia, and the harga satuan are also being taken directly from the market price in Jakarta. So here are the list of the workers and also the wages of the workers itself. And also we are also showing the price of the unit price of the equipment that are used in these activities. So the unit price on these activities is approximately at 417,000 rupiah. Next, still on the working of bore piling, the next activities is the reinforcement work for 1 kilogram of steel for board pile. Again, the coefficient are taken from permen of from Indonesia government, and the unit price or the harga satuan is directly taken from the market price at Jakarta. And here are the lists of the workers that are needed and also the total wages that are need to be paid on its unit price, and also the materials that are used are the reinforcement itself and several wiring, and therefore we can conclude that the unit price or the harga satuan pekerjaan is approximately at 13,000 or 14,000 rupiah. So the next work activities is the casting of FC30 concrete for board pile. So again, the coefficient are taken from per man, and the unit price is taken from the marketplace at Jakarta, and therefore, by after calculating, we found out that the total unit price for the workers, the equipment, and also the materials are around 1.2 million rupiah, and we also take the some overhead around 11%, and therefore the total unit price of this working activity is around 1,358,000 rupiah. The same way with these working activities, still on the work of bore piling. So here is the analisis harga satuan pekerjaan of 1 meter square casing installment for slough and pile cap. So the total unit price for the overall of these work activities is around 176,000 rupiah. Still on the working activities of slough and pile cap, here are the uh, analisis harga satuan pekerjaan of the 1 kilogram reinforcement bar installation. So the total unit price for these activities is approximately at 114,000 rupiah. Here is the table showing the AHSP of FC30 ready mix concrete casting. So again, the total cost unit price for the equipment is at 1 million rupiah to be approximated, and the total unit price therefore in this for these working activities after being added for the overhead is 1,175,000 rupiah. Moving on to the activity of 1 meter square curing process for slough and pile cap surveys. For these activities, the total unit price for the workers, the materials, and the equipment is approximated to be at 983,000 rupiah, and being added by the overhead is around 108 thousand rupiah, and therefore the total unit price of these working activities is 1,091,000 rupiah. Lastly is the activities of 1 meter square removal of casing on the slough and pile cap surface. So for the total unit price for the workers, the equipment, and also the materials is only around 8,000 rupiah, with the overhead of 908 rupiah. Therefore, the total unit price of these activities is around 9,000 rupiah. After conducting the analysis on the unit price per unit for each activity, so we combine all of the result from our analysis within this table. So this table is called as the bill of quantity, or also known as BOQ. So this BOQ is belong to the working method of bore pile, and as we can see that the first activity of this working method is the bore point setting, followed by the boring process and casing installation, with a total volume of 8,580 meters. So this value is obtained uh, because the amount of piles is 572 piles, with each pile has a length of 15 meters. So we just simply multiply 15 meters with the amount of pile, which is 572 piles. So the next activity is the reinforcement bars installation. So after calculating uh, the volume for this activity, we obtain that the total volume for uh, installing the bars for all of the 572 piles, uh, it needed around 44,088 kilogram. And next is the casting process. The total volume will be around 2,426 meter cubic, and there will also be a test that will be conducted. First is the actual test. So this test will be conducted as much as 3 times to three different piles, and then the actual test that will be conducted 10 times to 10 different piles. And lastly is the compression tension test that will be conducted once. So the row that are showing the price per unit is actually the result from our previous analysis. So for calculating the total price for each activity, we just simply uh, multiply the volume with the price per unit, and therefore we can do the math calculation regarding the sum of the or the grand total uh, of conducting bore pile process uh, within the project. So we conclude that the total cost for conducting the bore pile working method is around 7,971,653,000 rupiah. For this is the table showing the bill of quantity for spoon piling working method. So as I mentioned earlier, since we are not able to have enough information in calculating for this working method. So these tables are obtained from the document, the existing project document, for the comparison materials. So first, the first activity is the spoon pile D600 millimeters procurement, with the same volume as the bore pile, with 572 amount of piles, and each piles have a length of 15 meters. So the total volume for this activity is 8,580 meters. And for the handling spoon pile, again, as there will be as much as 572 points for the pulse. So therefore, the total volume for these activities, together with the whole handling and the bow plank and marking, is 572 points. And the next activity is the piling process itself. Again, the total volume is 8,580 meters. And the next activity is the spoon pile connecting and treatment. There will be a total of 572 points, and the dolly working will be, the total volume for this activity is uh, 1,716 meters. There will be a total of three actual tests will be conducted in this case. And the same as the bore pile, there will be 10 PDA tests, or the pile driven analyzer test, that is conducted to the 10 different piles. And lastly is the compression tension test that will be conducted uh, in only one pile. So again, the price per unit are obtained from the existing document of the project. The same as the bore pile, the method to calculate the total price is simply multiplying the volume with the price per unit. And if we do the sum up, the total expenses, or the total costs that are needed in conducting the working method of spoon pile, is around 11,876,786,000 rupiah. By viewing on both table that contains the bill of quantity for both bore pile and spoon pile, it can be easily determined that the most efficient foundation construction method in terms of the cost analysis is the bore pile, that has only a total cost of 7,971,653,000 rupiah, while spoon pile has a total cost of 11,876,786,000 rupiah. Based on the BOQ itself, it can be concluded that the procurement of precast spoon piles consuming a very high cost, with 8,021,442,000 rupiah, beyond the total cost of bore pile construction method, contributing also contribute to the expensive total cost of implementing the spoon pile as the foundation construction method at R.S.A. So this can happen due to their weight. Precast piles require a special equipment for handling and also installation. Therefore, by implementing bore pile as the foundation construction method, the total construction expenses can be cut as much as 3,905,133,000 rupiah. And this method of foundation construction is favorable to be chosen in terms of the cost effectiveness. However, based on time analysis, the spoon pile will lead to a shorter working duration as compared to the implementation of the bore pile as the foundation construction method at RS-PON. Referring to the critical path method shown before, it can be concluded that the whole process of the bore pile consume a working duration as much as 92 days. This is due to the requirements of boring processes, casting until curing process before the pile could be tested on different types of tests. However, as it is referred to as the critical path methods of spoon pile, it only takes a duration of 60 days from the starting point of the construction method. Therefore, this result is proven by several studies that also declare that spoon piles takes a shorter duration of working process than the bore pile due to its fast installation of precast pile that has been fabricated in the very earlier before the process of foundation construction is actually being started. So, by considering both criteria, cost and time calculation, either spoon pile and bore pile has their own strength and also disadvantage. So, spoon pile is best on time efficiency, while bore pile is perfect on fulfilling the cost efficiency. Therefore, another criteria and factor should be considered, such as the cost and also the effect of implementing either the spoon pile or the bore pile. So referring to the general timeline, which provided on the existing CPM of the overall work of the substructure, including ground soil work, the target is 107 days. And moreover, by taking into account that substructure is very crucial in the working phase that marks the start of the upper structure of the building as a whole. So choosing bore pile as the foundation work method is not the best option on time wise, as it is almost impossible to perform a ground soil work with a tight time span, as the process of boring has consumed a very huge amount of time. And not only that, the drilling process involved in installing bore piles often result in the accumulation of excavated soil and slurry, which can create mud and also debris around the project site. So additionally, the use of drilling fluids such as water can lead to spillage, creating wet and slippery condition that can spread if not properly contained, further impacting the cleanliness of the project area. This requires effective disposal and also management to prevent the area from becoming unsafe, which will consume another huge amount of time or duration, and also uh, money. Therefore, choosing spoon pile as the foundation work technique is the best decision, as choosing bore pile while put the project at risk in terms of the general schedules.
So now we'll move on to project quality management. The following is the quality metrics that we have made for the spoon pile foundation work. It consists of quality of material, the dimensional accuracy, defect on material, vertical alignment of pile, bearing capacity achieved, and the age of material, which we will discuss in more detail on the following slides. First, we will discuss about the quality of material, where the quality of material itself should be confirmed whether they have met the requirement, whether it is suitable and correct materials that fulfill the requirement of our construction. This confirmation can be done by multiple ways. First of all, is to conduct a material test to check if the material has any sort of impurity which would affect its capability. We can also conduct a mechanical test which can ensure that the material can withstand regular use without failing. Next one would be dimensional accuracy, where it is very important to make sure that the dimension has met the requirement, because if it does not, then there is a huge possibility that there will be a structural failure, because lower dimension may not be capable to withstand the design load of the building. And how this dimensional accuracy can be achieved is by using uh, many sort of different measuring instruments to check whether the dimension of the pile has fulfilled the requirements stated on the specification of the material. Next is regarding the defect on material, and in this case is the defect on spoon piles. Defect on spoon piles can very much affect the quality of the spoon pile itself, lowering its strength and also increasing the risk of structural failure. However, defect on materials can be simply checked through its physical appearance. Next is the vertical alignment of pile during hammering. This is important because if the pile is not aligned correctly, it can actually give additional problems and additional loads such as movements, deformation, and others, which would eventually lead to cracking or defects on the pile itself. And this vertical alignment can be achieved by ensuring that the pile driving rig is properly leveled and stable during hammering. Also, a continuous monitoring using inclinometers and laser alignment tools can also help on ensuring the vertical alignment of pile. And during the hammering process, it can actually be separated into several stages, and on each stage, it should be monitored that the pile is correctly aligned. Next would be on achieving the bearing capacity of the spoon piles themselves. And as foundations are considered as the main core of a building stability, it is very crucial for piles to be able to reach its design bearing capacity, and through this, it can ensure that the structure can hold its design load. This can be achieved through multiple testings. First is through actual load tests, where the result from the monitoring of the test should not exceed the expected allowable settlement of the pile. Next is to also conduct a pile integrity test, which can detect any sort of defects such as voids, cracks, or necking within the pile. Next would be the age of material, and in the case of spoon pile, since it is made out of concrete, it will reach its maximum strength on its 28th day, starting from its curing stage. And in the case of a spoon pile that hasn't reached its maximum strength, it should be separated away from the other spoon piles so that it will be given more time for it to reach its maximum strength.
In the process of lifting the spoon pile in the working site, there are some procedures as well as the requirements that shall be followed in a way to make sure that the spoon pile's quality is maintained physically. First of all, the specification regarding the product shall be known, such as the weight, dimension, or length, as well as the technical properties. These specifications help in choosing the type of or capacity of the crane which will be used for lifting the spoon pile precast concrete product. Not only knowing the criteria of the spoon pile, the specification of lifting sling and hook of the crane shall also be determined uh, to make sure that the crane has sufficient strength to mobilize the spoon pile and maintain the safety throughout the lifting process. And to determine the capacity of the sling, we can use the formula that are shown in this slide, uh, which is the factor that will be multiplied by zero point 0.5, and the weight of a matter of product and also its length. The method of storing precast spoon piles must be considered in order to preserve the pile's quality. There are several available methods to store the spoon pile. namely accumulation at stockyard or site, and also pyramid accumulation at stockyard or site. However, in this case, the chosen method is the pyramid accumulation on site. And in conducting this method, there are some requirements that shall be followed, such as the wooden wedge placement and also the type of the wood itself, and also the number of stacks of the spoon pile. And it should also be mentioned that since the diameter of our spoon pile is 600 millimeters, so therefore, based on the table shown on this slide, the amount of stacks should be maximum of two, and an area has also to meet the several conditions for it to be suitable as a storage area for the spoon piles. And in order to find an ideal location for a spoon pile storage area, there are several steps that can be done. So first is to observe the surface condition on the field. The area has to be flat and also compact. And to achieve such condition, a soil compaction process can be done with the use of a stamper. And there should also be no puddles of water present at the area of the storage. And if this condition are not met, there are treatments that can be done, such as the surface leveling with the use of wooden beams or slipper concrete. These treatments, however, are entirely optional if the area has already met the required condition. So therefore, these requirements are not necessary. So for the quality assurance, by its definition, it is a structured methodology which designed to outline the process and also systems that are necessary to ensure that construction project meet established quality standards. So in a way to ensure the quality assurance are achieved successfully, therefore some effort shall be made. So first is to have a verification on the sample material. So since a vendor is needed in effort of providing the precast spoon pile, the audits toward the relevant vendor shall be done. This is to maintain that the production of the precast spoon pile is in accordance with the requirements set by the standards with regards to the step and also material certification. Um, for instance, the process of mixed design is taken based on the standards according to the target strength of the precast spoon pile. The vendor should also provide the sample which will be taken into a further test both on the materials and also physical properties as well as the strength. And as the sample is approved by the structural engineers, the sample will act as the benchmark during the production of the precast spoon pile itself. Next is the training and competence. So we need to make sure that every worker that is involved within the whole process, starting from the procurement until the piling, as well as the testing stage, need to be trained and have enough experience or even certification and qualification. So this is to make sure that the product quality is maintained throughout the whole process which are conducted. For instance, truck crane workers must have a permit from the relevant institution. And not only that, the amount of personnel shall also be taken into account to ensure that the working process is efficient and safe at the same time. As for another example, a minimum of four workers will coordinate the position of the product to be unloaded from the truck, and two people in the fleet, and two more people in the product stacking area. Uh, fa- and next is the documentation process. So we need to make sure that every process of the quality assurance need to be documented and also recorded in a form of inspection report. This will help in tackling any problems regarding quality matters, specifically on the precast spoon pile, which might happen in the future. Every inspection report shall be made according to the true condition and shall be reviewed as well as approved by the relevant stakeholder. So here are the list of references that are being used in assembling our major assignment. So here is the end of our presentation. We hope that all of the informations that are presented within these presentations are clear to be understood. Thank you.